ম্যাডাম স্টার্ট করছি আমরা।
ঠিক আছে। Hello. We are starting the live session of the NPTEL online course on symbolic logic. You know me, I'm Professor Chhanda Chakraborti, and we are here to take your questions, to discuss if you have any question for me. So I will start out with some questions that has been sent to me. You have submitted the questions and it has come to me, so I'll start out with those. In the meantime, what you can do is to send other questions through the chat window, which is open now. I find that Ms. Neetu Giri has sent a question. The question is why I have not received videos or notes regarding the same. I'm not sure whether this is addressed to me, but it seems like the material that she's looking for has not reached her, but I think that is what should be addressed to the NPTEL team and not to the faculty who's teaching the course, because I'm not personally sending any videos or notes to anybody. Those are actually available through the NPTEL portal, where you are looking at the course videos. Already the lectures are uploaded and the transcriptions are also available, and similarly the videos are also there. Every week they are made public. So if there is an issue with your not receiving those, kindly look into this from the technical point of view and send your queries to the NPTEL team. I hope that answers your question. The second question is from Sudhir. The question is, what are the application of PL in business process management and its use in workflow management? I'll repeat the question. What are the application of PL in business process management and its use in workflow management? The question in itself, Sudhir, is not directly connected to our course. What you're asking for is a very specific area, and whether the propositional logic that you have learned so far, by the way, the PL stands for both propositional logic and then also predicate logic. For first order predicate logic we call it FOPL, but often it is called also the PL. But I think at this fourth week you are referring to propositional logic by PL, and you want to know whether there is any application of propositional logic in your area in workflow management. I believe you're working in a company, yes, in Nokia. So workflow management, as I understand, is a purely management process, management procedure to clear up the steps that you need to take towards a certain end. I remember that there was a paper on application of propositional logic in workflow management. It came out in 2010, I suppose, and you can find it in Applied Mathematics Journal. What they did was to use both propositional logic and graph theory. So graph theory and propositional logic to work out an algorithm for application in specifically in workflow management. You may take a look into that, but there are other kind of applications also possible, perhaps, provided you can convert the steps that you have in mind into propositions. Propositions that are amenable to the analysis of propositional logic. So there are possible applications of propositional logic in specifically in business process management, but one has to work at it. Your requirements will be specific. So, keeping those in mind, the applications will have to be decided. This is how far I want to go with that question for the time being. I hope I have answered your question. If not, let us know in the chat window, and this is for you, Sudhir. The third question is from Varsha Murugan Patan Katiyar. She is asking various applications of logic in different industries. Again, a question, Varsha, which is not directly connected with the course content. You are just barely learning the elementary parts of logic, beginning, right? And you already are interested in what could be the applications in different industries. The curiosity is good, except that I thought that I would get more questions on the content itself, but I will take that question. From what limited knowledge I have, I know that it depends on the industry to find out what could be the application of propositional logic. Computer science persons will tell you that propositional logic and predicate logic both are staples for them. So, any industry that utilizes computer science knowledge, you will find applications of these, some sort of an application of these in those industries. If your industry is such that you use artificial intelligence, if your industry is such that you use some of the search algorithms, if your industry is such that you use logic circuits, then obviously you will find that propositional logic is very much applicable to that industry. So, there are applications, basically what I told you, that there are applications of this logic, and it depends on the nature of the industry. It depends on the nature of the product and the service that your industry is offering. We have found it in electronics, obviously, and also any even IBM development, or where they have thought about a certain specifications to be changed by artificial intelligence. That is where they have applied. We also know that theorem solver or proof solver, these days a lot of people use automated theorem proofing. If your industry uses this, then in that propositional logic will come conveniently helpful. So, again, what I said is there are applications, it depends on the industries, and I have given you some examples, but you can look up for more on these details about the applications that I mentioned. The fourth question is from Dr. Arup Jyoti Sharma, who is a faculty himself, and I like this question. It says that I have no question, rather thanking you for coordinating this course. So, thank you, Dr. Sharma, for thanking me for your question, but not question. Yes, it's a pleasure. It's a pleasure to coordinate this course, because I think logic is not given its due importance in many of our curricula all over India. I have been teaching this subject for many years now, and as years have progressed, I have found that it has interests for different groups of students. Here at IIT Kharagpur, I teach students from across the disciplines. It is a breadth, practically a compulsory subject for the computer science students, but then in my class there are also electrical, electronics, there are civil engineering. My point is that it has appeal, different kinds of appeals to different kinds of students. So, I like to bring it in this way. I like to bring logic to various populations, and the NPTEL online course has been such a forum where I can reach out to people even outside our usual domain. So yes, it's a pleasure and pure happiness, and I look forward to coordinating this kind of course again. Earlier I have conducted professional short-term courses on logic and applications of logic. I have also done winter courses, summer courses on logic and applications of logic. Through Gyan also I have taught logic. So this is my NPTEL foray, and thank you for appreciating this. Now this ends the questions that we have received. Are there any question on the chat? Is there any? Okay. So far there is no other question. In general, I hope that the lectures are useful and comprehensible for you. I have tried to explain it as lucidly as possible, but still if you have any further queries, then please join this live session and send in your queries so that we can have a talk, directly one-to-one talk. Yes, feel free to send in your questions. This is the hour that we have set aside for you. So write down your name and send in your queries. Let us see. It might be the question of many, but they are not speaking out. Do send your queries. What is this? This is a rejoinder from Sudhir Malik, who says yes, up to an extent, meaning I have been successful partially to give you an answer, and now I have to look for my answer. Okay, good. So thank you also. Look up some leads, and I'm pretty sure that you will find some information at least. Some people have tried. We are still waiting for some questions. So, I'll try to anticipate some of your doubts perhaps. I think there were some people who were a little bit unclear about what exactly does this validity require from a deductive argument, because there can be situations when the argument seems to be apparently valid, but there is a suddenly we find that there is possibility, and then premises are true and the conclusion is false, and how does that make the argument invalid? I'll take that as a conceptual question. We do not have any example in front, but let me just elaborate that point a little bit, that you see, in terms of truth table, because you have now been looking at ways to establish validity, if you look at premises are true and also conclusion is true, then in case of deductive validity, it is not enough that you find only one time slice or one particular moment when the premises are true and the conclusion is true. Rather, the validity speaks in terms of an impossibility. It speaks about that it must not be even possible ever, or in other words, it should be impossible that the premises are true, but the conclusion is false. So, no possibility, not even a fraction of a possibility. This is what the deductive validity requires. So, in terms of truth table, you might find in the truth table of an invalid argument that there is a row where premises are true and conclusion is true. But in the same truth table, you might find that there are other rows where the premises are true and the conclusion is false. Same truth table. So, which means that there is one moment or a period where you have found that the premises are true, but the conclusion is also true. So, there is a possibility of all of them being true, but there is also a possibility in the same truth table you can see that the premises are true, yet the conclusion is false. What can we infer from this? The answer that this logic would tell you is that the argument is invalid. The smallest of the smallest possibility, or even one such case, one possibility is enough to establish that invalidity. The opposite is not true. One such possibility does not establish that the argument is valid. There you have to look into that it is not at all possible, never ever possible, that the premises are true, but the conclusion is false. So, that is the difference between validity and invalidity, and keep it in your mind that deductive validity is like all or none. Either the argument is valid or the argument is invalid. There is no in between way, there is no degree of validity or degree of invalidity. Either it belongs to this category or to that category. I thought about mentioning this because I think I saw the semblance of this doubt in some of the questions posed in the forum. So, at least I could utilize this time to answer that. We are waiting for your questions. So, feel free to send them, write what you think about the course, or if you have any further queries regarding any of the so far what has been taught. We are actually in the middle of the course. There are still few more weeks left, but so far what you have learned, whether there is any question regarding the assignment, if you have any question, and so on. For those who are joining now the live session, we are still answering questions, and please send your questions our way so that we know what you're thinking, and also we can help you to clear up some of the doubts or any confusion. The question is from Sudhir Malik, who says that it would be nice if you please dwell on differences between Indian logical system and Western logical system, Oriental and Occidental differences. A very nice question, Sudhir, and I wish I can do justice to this question in such a short time. First of all, we don't get much of a chance to speak even about the Indian logical system, but there is one, and it is distinctively different from the Western logical system. There are similarities, there are similar principles, but ultimately the system is very, very different. So, if you are looking for Indian logic, then we will find not as a separate system altogether, because our theoretical traditions have been such that very heavy conceptual thinking has been put in the cloak of logic, or arguments have been used to argue for some precepts which are not really logical in character, but perhaps spiritual in character, or sometimes ethical in character, or sometimes about topics that are purely epistemological, meaning regarding knowledge, knowledge acquisition, and so on and so forth. But they have used serious logic. Which schools do I have in mind? Particularly the name of the Nyaya comes to my mind. It is a school of thought which has worked on logic even in the subsequent periods. So, there is Nyaya system, we are talking about Gautama and others, but even afterwards, say 15th, 16th century, we have the Navya Nyaya or the Neo Nyaya logical system, which are far more sophisticated and rather complicated kind of logical discourses. There is logic also in Vedanta, particularly in Advaita Vedanta. You will find arguments where logic is seriously used. Buddhists had a very well developed logic system. In fact, several logicians starting from Nagarjuna, Dharmakirti and others are really celebrated logicians in our own tradition, in Indian tradition. There is Jain logic also. Jainism had its own kind of logic, which, for example, instead of 2 values, truth and falsity, they used 7 values. So, these are systems which used logic. Now, you want to know the difference. I first said that these are the different Indian logical systems that were there, that are there, and work has been done on these. Even today people do research on these, people work PhD thesis on this, doctoral thesis on this. Western logic, on the other hand, is I would say there also the traditional or the standard classical logic is starting from Aristotle. What you are looking at in the course is what we would call the classical logic, I mean conventional classical logic. Many of you know that there are other alternative logics available. One very popular alternative paradigm is the fuzzy logic. Then there are temporal logic, modal logic, there are different kinds of logics also exist in Western logic. The differences are in where they start from, which principles that they use. So you might find that in Indian, one of the Indian logical discussion is about vyapti. How do you make two thoughts connect? How can you say that wherever there is a smoke, there has to be a fire, for example? What is that relationship? What should be the conditions for establishing this vyapti analytics? This is one ancient discussion. There might be similar discussions in Western logic, but as you know, any discussion, any intellectual discussion depends on the context, the time, as well as the society that you belong to, where the society is at. So, the nature of the logical systems, I think, are partly determined by these environmental factors, where by environment I mean the societal environment, which you cannot deny. So, that permeates into our thoughts and that shapes. So, the topics are different, the beginning points are different. For example, they all of them may not talk about Boolean algebra, but just because Indian system does not speak about Boolean algebra does not mean that they are deficient in that way. So, we are comparing here apples and oranges. True that they are fruits, but their kinds are very, very different. So, this is how far I want to go with this question, because it's like opening up totally a semester long course again. And since many of us do not know much about Indian logical system or about the Western logical system, so let me put a stop here. But I want to say that there are not only differences, there are similarities too. But essentially these are separate systems and different systems. Thank you for the question. Anybody else has any other question? Particularly our student friends, for whom this live session has been particularly thought of, that they would finish their academic engagement and then come for the live session. I would like to hear from you, and I have set aside all my work to come and attend this. So, please send your questions. Let me hear from you. Are there any questions on the chat window? We'll wait for a couple more minutes, and if there are no other questions, then we'll have to close the live session here. Oh dear. This is a question from Ranjani Priya, who says, Madam, please say a short note on all the topics that you have taught. It will be useful for all of us to recollect. Ranjani Priya, can you send me the list of things that you want me to talk on? That is easier, because it's not that it's in my memory what I have taught. So you please send particularly the ones that you want to hear about, and then I take them one by one. If necessary, we'll try to recapitulate on that. But questions, those are helpful, because the gaps I won't be able to identify otherwise. If you send me the question, it's much better for me to even respond where you understood or where you might need a clearer understanding, So help me here, all right? I'll wait for you. Sudhir Malik says, for complex connective, please elaborate unless. Unless is not a standard connective, meaning the 5 connectives that you have, unless is not one of them, but what we are trying, the level best, is to capture what we can with our 5 connectives. So, P unless Q, can I use your pen please? Give me the other pen. Yeah, thank you. So, I said P unless Q. So, default is P. P happens unless Q happens. So, one of the translations that we can do with our 5 basic connectives is if Q does not happen, P happens. So, P happens unless Q. So, which means that as long as Q is not happening, P is going to happen. So, one translation is not Q, horseshoe P. This is what we said. And when we are going to look into the equivalence rules, you will find that not Q horseshoe P is actually equivalent to Q or P. How? Well, for that I will have to explain to you. You just have to bear with me. Not Q horseshoe P, if you convert it into a wedge, it's going to be not Q or P. That not Q reduces into Q or P. So, either Q or P. This OR, by the way, is not an exclusive OR, right? This is our inclusive OR. So, in that, just a second please. So, the unless has to be treated, I think, because you are beginners. So, we will go with the horseshoe understanding. This is what I said in my lecture also. We will go with not Q horseshoe P, and I will explain once more why we are doing, because P is default unless Q happens. So, when Q does not happen, that is your not Q, then you can assume that there is P. This is our translation. Sentence, I think I have used in the lecture, so I am not going to give you that kind of a sentence example right now, but in general this is going to be the schema for tackling unless. If you have access to my book, the book that I have written in logic, it is available in various places including Amazon. So, in that you will be able to see a discussion on this also. So, feel free to look it up. Okay. Kiran Kumar says, hi madam, this is, sorry, I have to. Yeah, Kiran Kumar simply says, hi madam. Hi Kiran, good to have you in the live session. If you have any question for me, please send in. Ranjani Priya has come back saying about truth tables. About truth tables, what is your query? I am not sure, but truth table is a procedure, right? It's a table that tells you something where you are going to see truth values. We are using the truth values of true and falsity. The table is going to have rows and columns, right? So, how do you figure out how many rows in the truth table? I said it depends on how many simple components you have there. The formula is 2 to the power n, where 2 stands for the two truth values that we allow in this logic, namely truth and falsity. The n stands for the number of simple components in the expression. So, if you have, for example, A horseshoe B dot C and you are trying to do the truth table for that expression, for that statement, then how many simple components you have? 3. So, the number of rows there is going to be 2 to the power 3, namely 8 rows. This is what we said. So, this is how you figure out how many rows they are going to be. Then the columns, I said you need to set them up. The first columns belong to the simple components. So, if you have A horseshoe B dot C, you have 3 simple components. So, there is going to be 3 columns dedicated to A, B, C. The distribution of the truth values, I said that the first component is going to get always R by 2 T's, consecutive T's, and R by 2 F's. Because you have 8 rows, so there is going to be 4 T's, 4 F's for the first component. The second one is going to get 2 T's, 2 F's, 2 T's, 2 F's and so on until you reach the 8th row. And the third one is going to have alternately T F, T F. This is what we are following. The remaining columns are going to be set up according to the scope of the connective. So, you go from the least scope connective to the maximum scope connective. Since the main connective is the one which has the largest scope, so the final column will belong to the main connective. This is how you set the truth table. Now, you tell me where is your question, what you did not understand and where you thought that you need to hear it again from. Is it about the setting of the truth table? Is it about doing the task with the truth table? You tell me and then I will try to answer you. But these are the general guidelines for setting up the truth table, all right. Those who are joining the live session now, again letting you know that this live session is specifically for you, so that you can have a direct interaction with me, with your questions, with your queries, with your doubts, with your need for clarification. So, feel free to utilize the time and send your questions through this chat window. Ranjani Priya says, thank you, ma'am. Thank you, Ranjani Priya, for coming on live session and asking this question. I hope I have helped you. I hope I have answered your question. If not, do let me know. Or if there are any remainder questions, send them. Even in the forum, feel free to post your queries. It's a pleasure to know your questions, and in whatever way I can, I try to answer them. So feel free to use that forum also to post your queries. The live session is only to give you more value, in that sense that you will have a feel of to talk to me and not wait for the answer. This is as good as having being in the same room. So utilize this, send your questions. I'm really looking forward to having your questions. How did you find the assignments? If you can let us know, that would be of help. And how many of you are students, and do you learn this subject in your college, or wherever you're taking classes. Symbolic logic is what we call, this course that I have developed, I call it symbolic logic, but sometimes people call it introduction to logic. I do not know, but in your college, is there such a course in your curriculum? If so, what are the syllabi? Up to where do you go usually? I would like to know this from the faculty also, because I think there are some faculty are also taking this course. So please let us know about this, and whether this course is being of any help to you to formulate a course, or even to understand the course that you are taking already in the college better, you know. So all this would be very, very useful feedback from you. So do let us know. Sudhir comes in to say thank you. Thanks a lot, Professor and the mediator. Thank you, Sudhir. Thanks a lot to you. You have raised many questions and very pertinent questions. Some of those I liked really. So thank you again. Are there more questions? Now, this is Sarvesh Pandey who's writing, I have doubt, which is good that you have doubt. But what is the doubt? Send us the question. What is it that you have doubt about? And I'll try to meet that. We have just few more minutes left, so if you have questions, send in quickly. Sarvesh Pandey has written, I have a doubt, and now he has sent again a half sentence saying importance of symbolic logic in engineering. Sarvesh, I think you are joining only, probably you were not here in the live session from the beginning, because while talking about applications in various industries, I have already mentioned that engineering, by engineering you mean a huge area. If you are thinking about any discipline in engineering, then let me just tell you that in my class at IIT Kharagpur, symbolic logic is staple for computer science and engineering students, but we get students from civil, electrical, electronics, aeronautics. In fact, you name a branch of engineering, we have students from there, mechanical and so on. So, if you think about importance, by which you are probably thinking about application, there are many. There is not enough time now to talk about all those applications, but in computer science and engineering the applications are clear and well known. In electrical engineering the applications are also well established and well known. In electronics the applications are also well known. It's that in general it is thought that logic clarifies your thinking, and if you know logic, then in a way it helps your thinking also, organization well. So, logic we say is necessary for all disciplines. Why just engineering? I have given you an answer here that it is important. If your next question is how is it important, I need to know your background, which engineering you are studying, or which branch of what branch of studies you are in, and then I will be able to give you a more precise answer, but it is important. Are there other questions? If there are no other questions, then I think we can now close this live session. There will be another live session next month because it's an 8-week course. So, by that time you are going to learn few more things, and I think there might be some queries also. In any way, this was a warm up session, and feel free. I will try to tackle questions as they come. As I said, even if you cannot come for the live session, then post your queries in the forum and you will get as much attention. This is an interactive session, so this is the nature of this is different. Other than that, the queries will be met whichever way you send them. Oh, Sarvesh, you are from chemical engineering. So, for chemical engineers, if you are into the chemical processes, workflow, then temporal logic would be of great help to you. Propositional logic is just the beginning, it's the first rung in the ladder, and then it builds up towards something else. But it depends on the kind of work that you are doing. If your engineering application doesn't have a scope for use of logic, then so be it. But there are possibilities where you can bring in logic even in chemical engineering. So, I think this ends our live session here. Thank you very much all of you who could attend this. It is always a pleasure to interact with people that I do not get to meet usually, but over this medium at least I could have a talk with you. So, thank you very much, and I look forward to next time. Thank you.